Good day, viewers. You are welcome to today's teaching. In today's teaching, we'll be looking at triangles. Triangles. So, triangle is a plane figure bounded by three straight lines. So there are three sides in triangle. So, and we have different types of triangle. Types of triangles. The first one is the equilateral triangle. We have equilateral triangle. In equilateral triangle, the three sides are equal. Equilateral triangle. Here, three sides are equal. And you know that sum of angle in a triangle add up to 180 degree. That means that this place is 60 degree, this place is 60 degree, this angle is 60 degree. So 360, that 360, 3 multiplied by 60 plus 60 plus 60, that will give us a 180 degree. So all the sides here are equal. Then the second type of triangle is what we call isosceles triangle. Isosceles triangle, that one is a type of angle in which two sides are equal. Two sides are equal. Isosceles triangle. This side is equal to this side. Two sides are equal in isosceles triangle. Then the next one is what we call scalene triangle. In scalene triangle, no side is equal. Scalene triangle. No side is what? Equal. This one is not equal to this, and this is not equal to this. A scalene triangle. Then another type of triangle is what we call right angle triangle. Right angle triangle. In right angle triangle, it is angle at 90 degree, and the two sides are perpendicular. This 90 degree. The two sides are perpendicular in right angle triangle. Here we have it as right angle triangle. Now look at the first one, equilateral triangle, isosceles triangle, scalene triangle, right angle triangle. Here all sides are equal. Here only two sides are equal. Here no side is equal. Here it rises at angle 90 degree, and the two sides are perpendicular. Now let's look at common theorems. The common theorems in solving triangle problems. The first theorem, theorem 1, is that of the Pythagoras rule. Is that of the Pythagoras rule. And what does the theorem state? The theorem states that in any right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Let me take it again. In any right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Now, this is a right angle triangle. This is a right angle triangle. Now, this is the hypotenuse. This is the hypotenuse. So the angle This one is facing this side. This is the hypotenuse. That means, let's say we have x here, we have y here, and we have z. For example, in a right angle triangle, from the theorem, the square of the hypotenuse. What is the hypotenuse? The hypotenuse is always the longest side, which is our x. That means that x squared is equal to y squared plus z squared. So that is the theorem. X squared is equal to y squared plus z squared. Now, for example, let's pick one example using this theorem 1 to solve a particular problem. Let's pick one example using the first theorem. Example 1. To show it is a right angle triangle. So this is the unknown side. Let's say this is A, B, C. A, B, C. Now, this place is unknown, and we have to find the unknown side. That is, find AB. Find the length, the side AB. Now, how do we find this? We follow that rule, theorem 1, which says that in any right angle triangle, the sum of the hypotenuse, the square of the hypotenuse is equal to the sum of the square of the other two sides. This is the hypotenuse that is unknown here, which is what? We can use x or y, or we can even use A to denote it. We are now looking for A. Going by the theorem, that means that A square is equal to 4 square plus 3 square. Now this one is a square. We take the square root of both sides. That means that A is equal to the square root of 4 square plus 3 square. That means that A is equal to 4 square, that is 4 times 4 is equal to 16, plus 3 times 3 will give us 9. That means that A is equal to the square root of 16 plus 9 will give us 25. What is the square root of 25? Is 5. So our answer here, that means that A is equal to 5. Going by the first theorem, that we can use it to find the unknown side. The square of the hypotenuse is equal to the sum of the square of the other two sides. Theorem 2. Theorem 2 states that in a triangle, that is, the sum of a triangle is equal to 180 degrees. The sum of angles in a triangle is equal to 180 degrees. The sum of angles in a triangle is equal to 180 degrees. What do I mean by that? That means that if we have something like this, for example, everything inside, let's say this place is x, for example, this place is y, this place is z. Now, the interpretation of this is x plus y plus z is equal to 180 degree. That is, the sum of angles in a triangle is equal to 180 degree. Let's solve one question using the theorem. The question says, find the letter X in the diagram below. Find the letter X in the diagram given below. We have 50 degree here, angles 80 degree, but this angle is unknown. This angle is unknown. Let's say this is A, B, and C. And we have to find X. The second theorem says that the sum of angles in a triangle is equal to 180 degree. So that means the addition of all this, that is the meaning of sum, x. Now to find this now, it will be x, the addition of everything, plus 50 degree, plus 80 degree, that is equal to 180 degree. So that means we're having x plus 50 plus 80 will give us 130 degree. 130 degree is equal to 180 degree. Our x is equal to 180 degree minus 130 degree. Our s is equal to 50 degree. So that is the answer to that, going by the second theorem. Going by the second theorem. Now, the other theorem now, that is theorem 3. The next theorem. This theorem says that the two opposite interior angle in a triangle is equal to the exterior angle. The two interior opposite angle of a triangle is equal to the exterior angle. So what do I mean by this? Now, if we have something like this, we have it like this. We have angle here, we have an angle here, so we have another one here, then we now have another angle here, for example. That is, this is the two opposite interior angle. This is the two opposite. This one is facing this direction, this one is facing the other direction, opposite. These two opposite angles is equal to the exterior angle. Or you can have a diagram like this, another diagram where we have maybe M here, and we have two interior opposite angle. That means it's equivalent to the exterior angle. It's equal to the exterior angle. Let's take example under that theorem 2, that theorem 3. Now we are to find M. Find M in this diagram. We have to look for M. M is the exterior angle. M is the exterior angle. M is the exterior angle. So what are the opposite angles? The two opposite angles are what? 75 degree plus 35 degree, which is equal to N. So that means that N is equal to 75 degree plus 35 degree. So that means that our M here is equal to 75 plus 35. We are going to have it as 110 degree. 110 degree. M is equal to 110 degree. Here is another example under this theorem. We have this triangle, then we have exterior angle, and we have two interior opposite angles. And the question is, find the angle marked X. Find this angle. Now, how do we find this angle? How do we find this angle? We go by the theorem. The theorem which says that the sum of the two interior opposite angle is equal to the exterior angle. So what do we have as the interior angles? We have it x plus 34 equal to 82. Following the theorem, that means that x is equal to 82 minus 34. That means our x is equal to 82 minus 34. We can just quickly do it. 82 and 34. It's impossible. This one is 8. We are left with 7 here. 3 from 7, we have it as 48. So our answer here is 48 degree. So carefully look at the example.